Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. Let's continue our lesson with chapter 4, which is potential. What you are going to learn in this chapter is, first, we will see the concept of energy. Second, we will see about potential. We have three different potential, and then we have energy density. For the potential, we have the first one, the potential difference, or in Malay we call as a beza mutlak. Second, we have absolute potential, or in Malay, upaya mutlak. The third one is a potential gradient, which is in Malay is kecerunan upaya. We will see these three potential later on. And last part, we have energy density, which is ketumpatan tenaga in Malay. Okay, refer to the figure. Imagine you want to move a charge Q from one point to another point. Okay, we have a Q here. Let's say we want to move in this point. Okay, to move the charge, okay, it needs to have a force or work done to the charge. So basically, the work done by external source. To move a charge Q along the distance L, okay, this is a mathematical representations where the work is equal to minus integration of F dot dl. So both units are vectors. So our integration is along the dl. Let's say this is a dl. And we know that the force is equal to the charge multiplied by the electrical field. So we use basically the negative sign in our analysis because the work is done by external source. So we can represent the work as a dW. dW means the incremental of work along the dl. So it's equal to minus QE dot dl. So the charge is within the electric field. So the total work done, okay, to move the charge in electrical field is equal to the integration of QE dot dl. For example 1, given the electric field E is equal to 100 amps minus 200 Y plus 300 Z volt per meter. Find the incremental work done to move a 20 microcoulomb charge at a distance of 6 micrometer along the direction of 2x minus 3y plus 4z. And the solution, the incremental of work is equal to minus QE dot dl. We can see here that our electric field and our dl is both a vector unit. When you do the dot product of two vector units, so the work is basically a scalar unit. Now fill in all the related information. So we have a charge Q minus 20 micro, and in bracket our E is 100x minus 200y plus 300z, and dot product with the distance, okay, which is 2x minus 3y plus 4z. So the dot product you have to remember. So when we have x, okay, dot x is equal to 1. If x dot y is equal to 0. So that means when the unit vector is the same, so the dot product will become 1. If the unit vector is different, so it becomes 0. So please remember that. With this knowledge, so we can solve it. Okay, 100 will be multiplied by 2, and then plus minus 200 will be multiplied by minus 3, and then 300 will be multiplied by 4. So our solutions is equal to 40 millijoule. Okay, this is can be put more negative here. Let's see example 2. Given the electric field E equal to Y in the direction of X minus X in the direction of Y volt per meter. Find the work done to move a 2 microcoulomb charge from 2, 1 minus 1 to 8, 2 minus 1 along A, the parabolic x equal to 2y square, and B, the straight line x equal to 6y minus 4. In these questions, let's imagine you have an electric field. You have a charge of 2 microcoulombs within the field. Initially, the charge is located at point 2, 1 minus 1, or I can rename it as point A here. And then we want to move this charge to another point, which is point B, 8, 2 minus 1. And basically the road taken for the charge to travel from point A to point B is different. Even the destination is the same. For A, we have parabolic. Maybe the road is like this. This is our DL. And then we have a straight line. Okay, we go straight here. So we have another DL. So the DL is given by these equations. That is the situation. So as a solutions, let's say we have the parabolic x equal to 2y squared. So the total energy W equal to minus Q E dot dl. So our E is here, and then our dl, we are using the Cartesian coordinates, so it's equal to x dx plus y dy plus z dz. Okay, so we just mesh everything, so we can see here, okay, we have the x, the vector x and vector y, so the vector z will not be used. And where is our destination from this point? 2, 1 minus 1 to 8, 2 minus 1. So this is the road. Well, when we solve this dot product, we have for component x, we have y dx. And then for the component y, we have x dy. And then for the x, okay, for x, we see here the x is from point 2 to point 8. So the x equal to 2 to 8. For point 1 is from 1 to 2. So we have 1 to 2. Then we have to change the y here, because we see here from these expressions, we can alter to be in the expression of y. Y is equal to what is search x over 2, or x x 1 over 2 divided by set 2. Okay, this is all. That's why you get here y equal to x 1 over 2 divided by set 2 dx. And then for y, because we want to integrate with dy, so x here is equal to 2y squared. So you have to change to 2y squared. And then you have to solve the integrations. And when you solve the integrations, so this is your final answers. So our energy is minus 9.33 microjoule. Okay, we settle to find the energy when we take a parabolic road. Okay, what happens if we just take a straight line? Okay, we have a straight line x equal to 6y minus 4. Right, so we use the same equations, and our QE also the same, QE.dl also the same. The only difference is about the what is the y and x in this case. And the point also is the same. X is 2 to 8, y is 1 to 2. So y here, what is y? Okay, from x equal to 6y minus 4, so from here you can obtain y is equal to what? Y equal to x plus 4 divided by 6. This is your y. That's why you got here x plus 4 divided by 6 dx, and then minus 1 over 2. So your x is equal to 6y minus 4. And again, you have to solve the integrations, and your final answer will be minus 8 microjoule.